involve some of the rules from chapter 2 and a bit some of the rules are that you need to have out only. Okay, but I think they are provided in your what you call that, the formula sheet. Okay, so should be, don't worry, you should be okay lah. Unlike my time, no any sheet are not given. So pretty. Oh, sorry, we are talking about SHEET, not I. So I didn't. So don't try to sing my word. Okay, now according to gravity, Newton's universal law of gravitation. You see, we saw this fellow again. Okay, him alone provide at least half of the engineering's formula. Okay, so according to this law, okay, Mr. Newton's universal law of gravitation. So when one body attract to other body in universe with a force which is directly proportional to the product of masses of two body and inversely proportional to the square of the distance between the center of the body, they are called gravitational force. So what he's trying to say here is, okay, this guy, blah, 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 what he's trying to say is actually F is directly proportional to M1, M2, and inversely proportional to R squared. This is what this whole thing trying to say. Okay, so when there is a body, no, there's two body. We are talking about the planet. If you are talking about human body, okay, one boy, one girl, so they will be automatically attracted together. Let's say, okay, so somehow, okay, between two body, they will attract together. So the attraction that occur between the first and second body, the attraction force is called the gravitational force, and is actually depends on the mass and also the radius. This R is not radius, it's actually the distance between the center of one and second body. Can you understand? So in short, when this is directly proportional, so we can change it into equals to a constant times this one. So the constant is called G, we call gravitational constant, 6.67 times 10 to the power of negative 11. Okay, and this is fixed, this value. So you have to have out. Okay, can I? All right, so now, okay, jot this down. Wait, because I think you might have a problem to write, because it's too small if I put it like this. Wait, so this will be the header. This will be your header. Okay, this will be a header, and then this is the law. So you need to mention like this. Okay, can okay. This one you can jot down, but my focus is this one. You have to draw this out. Okay. Don't let me know. Yeah, done. Yeah. Oh yeah. For your 2 weeks holiday, I might need to do replacement, because you see, last week I'm not around for 2 days, actually 3 days, but somehow I need to do the replacement, Yes. Ken, you are allowed to join via Google Meet. And I have to mention, for tomorrow, because I have to send my mother to hospital. I don't know when I can back in KL as well. So, well, you are having exam when, chemistry? Huh? Chemistry today, right? So, okay, I can't do anything because last week I got an emergency. I was banged by some series of issue. Okay, yeah, because it's a sudden happen one. It's like a big truck crashed my head. Okay, so that's why even by Friday, Friday is it we are having bio. I was not really that still blurred. Okay, now tomorrow, because tomorrow I have to send my father to hospital. I'm not so sure whether I can back on time or not. I will try. So you guys have to check your handphone for the group. Okay, done. Yes. Okay, good. Now for this one, so that's why you see, because the attraction force is involved, you see, is directly proportional to the mass. So in some sense, the bigger the mass of the body, the higher the gravitational force. That's why you see why planet were able to orbit around the sun, because sun has a huge mass, okay, which will create a huge gravitational force that force them to orbit via the what you call via the shell, I mean the orbit lane, and they are not pull around. If let's say the gravitational force is not that stable, you will find that okay, after 1 year, the Earth is going farther and farther away, like that, because it's not so stable, Of course lah. Why is stable? Why is stable that they can follow the orbit? Because the attraction force is not just happen between. It's not just happen like sun attract the what you call the planet, not just like that. At the same time, the planet also attract the sun. So that's why both sides, so that's why they can hang together. It's like let's say, next time, you and your boyfriend, for example, if you are not both attracted, then you got a problem. Okay, you will get bye easily. Something like that. Okay. Why Kitahana? Kitahana has a what? And has what? Ugly boyfriend. Maybe in your eye ugly ma. In his eye, in her eye is very handsome ma. How you know? Later he think that her boyfriend is like BTS. How you know? This is in Chinese. We say how to say carrot and vegetables. All have their own. Every people have their own favorite. Okay, now, so under the Newton's third law, we are talking about the action reaction. Okay, so you see, for each action, there is an equal reaction, but in the opposite direction. That's why for every force that the Earth impart to any object on it, there will be an equal reaction force, but in the opposite direction that is imposed by those objects on the Earth. Although we see the object fall to Earth, but we never say the Earth is fall towards the object, right? So this is why, because the mass of the Earth is much bigger, so it imposes a great force to exerted from the equation F equals to ma, because the m is very high for Earth. So and a is equal to F over m, so the acceleration become very small. You see, very small. Why? The mass bigger, the acceleration very small. So that's why when we try to calculate, like I said, both body they attracted each other. Why we never saw like the object move to the, we won't say like the Earth move to the object. Why no? Because you see, F equals to ma. M is very big. The A will be very small, where A imposes the gravitational acceleration. So M very big, A very small. So maybe there's a movement, but it's not that huge, not that fast that your eye cannot see it. Very small. Okay, so we can't say like there is no movement at all. Okay, like you must keep bearing in mind, both body, no matter how big the difference between the mass, they will still attract to each other. It's just that one move faster, one move slower. Okay, can you understand? So it's like why we say like that? For example, when you are trying to slack, for example, when you try to slack, okay, the moment you slap, you anyhow the motion, you will saw like after you hit, even if I didn't saw it, after we hit, you see it will be a slightly movement, correct? Why you want to although we did say about slap, why you want to slap your own face for testing? Okay, so something like that, you see, so the big one, when you go pop, okay, you will back to the nearest one. Why? Because the moment this one move fast, that's why you saw like what you saw is this one slap is, let's say, is this one's A, this one's B, A slap B. You just saw A is moving. Does B doesn't move? Actually, the moment you slap, it is moving. It's just that the motion is small, so you didn't realize it. So same goes here. A pencil dropped on the Earth. The Earth moved? Yes, very slightly. Why? There is a force there. Remember, attraction is happen on both body, between both body. But because the M of Earth is very big, so the acceleration will be very small. So it's almost negligible. Means that we can almost ignore it. Too big, it's like the sun and the Earth. Why only Earth move around the sun? You are not seeing the sun is moving around with the Earth as well. Why? Because if compare like sun's The planet of Earth is like a sand, tiny bit of sand only. So the difference in mass is too big. So the gravitational acceleration is very small. So it's like almost not moving. Okay, try to imagine F is 1, let's say 1 over 10 times power of 10 times something power of let's say 66, almost equals to 0, correct? So this is why we can't say almost equals to 0 is 0. No, it's just like negligible. Okay, so this is something like why I have to let you know this, because later on the formula downward next when we try to calculate for the motion is actually involve both sides. Later on you will ask again. So that guy is moving and only the satellite is moving. Why we need to include the Earth? Because they are actually attracting each other. Okay. All right, now. So that's why it become very small when the mass become very large. So the impact of gravity is greater if we look at the attraction between the Earth and the Moon. And both mutually attract each other, you see. And it is not as the Earth is attracting the Moon alone. No. Both are attract each other. That's why it creates a force. So when it creates a force, both sides pull together. Right? Let's say Gita, Hana, and Logus they are like trying to have a same crush. So they are pulling the guy in the middle, like pulling. So in one extent, that guy will just stay there, right? Because both sides pull, so it will stay there, right? It's like, okay, now this one in the middle, I pull this and pull this, so they will fix in the position. All right. Now this is how the relation between the planet and the sun. Same goes to all the attraction. Boleh faham? Why they say like that? Because there is a pull from here to here, and and at the same time there's another pull from here to here. So both cancel out each other. So that's why I stay like that. Okay. Done, can okay, all right. Jot down, I think better jot down, because this one is actually, although in your textbook it just mentioned, but this is for me, this is actually the theory that makes our calculation logic, something like that. So you better jot down, at least you understand after this, hopefully. Yes, what's wrong with you? Yes.
Like we put a pencil on the earth will move, right?
Yes.
So it was it's moving as the earth moves.
Yeah. Somehow it's just that the movement is very small, which we can neglect it, and at the same time there's another force will cancel out the movement as well, because not just you alone, the only car moving on the earth, there are many cars moving. So here there's one car here, so they will drag each other, so cancel out. If something is not moving, doesn't start is stay at the same position, doesn't mean that it does not move. It's just achieve dynamic equilibrium, we say. Equilibrium means that cancel out each other, net is 0. Dynamic means what? Dynamic means that in and out is the same. You in and out is the same, then they cancel out each other, so kosong. So now, let's say if we try to imagine, okay, you use your imagination. Let's say time is an element of physics, right? Now, for every second, our time will keep moving, right? Right? According to us, every second and every 60 seconds is 1 minute, right? Why is moving in the same pace. Should be according to the law, right? Time is something constantly moving, and it will be always in the same unit. Should be that time, right? So why it will keep moving constantly? Because it already achieved equilibrium, dynamic equilibrium. Dynamic equilibrium doesn't mean that it have to stay there. If achieved dynamic equilibrium, it will be like, oh, I didn't do anything, my time is stopped. Then at the same time, you are doing your own work, your time is moving. Then after that, we try to check the mine is 4 o'clock, she's already 10 o'clock. Then the sun will be like, oh, my side very bright, her side already dark. Nonsense, man. So why this happened? Because this is a theory lah. This is just a theory, haven't been proved. Why? Because our technology are not able to study, are not able for us to research on time. If you can research on time, means that you are like Doraemon already. Doraemon, you can go back to the time. You can go back to the what you call using the time machine. Okay, there are two things, two elements in physics, which is how to say, which is can be studied so far: time and space. It's easy to understand. You can change space. Volume, can you change the volume? No, why? Because the space is fixed, all right? But actually, according to theory, if you go until 5 dimension, we can change the space, so-called theoretically. Nobody proof. If you get proven, if you can prove this, for sure Nobel Prize, for sure. But there is a very important thing you need to do. You have to let them know you are my student. It's a very good promotion, you see. Let me know lah if you already get a Nobel. Then I'll try to get a uniform for you. At the back, I put my own face, big one. Then your teacher always like to do like this. I do like this. Right? I can't show a middle finger like that one. No lah, just joking lah. Not really like to do that. It's embarrassing. That kind of shit. I'm not like the Donald stupid Trump. He can promote himself. Sorry, I can't. Đó đó. You move your mouth, you have to move your hand as well. This shows that you have a very good relation with these girls. Why? Because they keep blasting you, you know. I have to let you know as a how to say, as an experienced guy, to let you know you can try to have a bad relation with boys, no problem, because boys normally restrict to each other. Girls don't. They are very, how to say, no. They like to keep everything in their mind, and they keep it to the heart forever. All right, now let's see. The moon orbit around the Earth as there is a gravitational force between the moon and Earth. So let's say one day, okay, every country now, the nuclear country all went wrong. They blast every single nuclear bomb in the world. Okay, then because nuclear can create, it's very heavy, it's a very big TNT, so it will create maybe, let's say, distortion. Let's say, for example, because gravity is something looks like there is a, how to say, there is a, we call the field. It's like a field called what, the Medan. You know what it means? It's like many lines go towards the Earth, the center of the Earth, man. Okay, if we imagine all these little bit gravitational force is a line, so means that there are many arrows towards the Earth, correct? So this arrow will create a field, because every single place inside that field there will be a gravitational force. So now when there is a gravitational field distortion due to heavy force, so like I said, every single people trying to blast the nuclear bomb. So what happened? It will create a distortion. No more gravity between the gravity field now went wrong. What happened? What will next happen? High chances the moon will straight away crash to the Earth. Let's say if this really happens, the moon crashed the Earth. It's not just that the Earth only will have a very big lubang like that. No, high chances the Earth bye-bye, because during the crashing, it will create a wave of force. The wave of force will like channeling into the center and break the core of the Earth. When core of the Earth break, bye-bye. This is just a what you call this? Is just a something will happen now. But actually, why the moon can orbit? Because you see, like I said, they achieve a balance between the gravitational force of Earth and also the moon. That's why they will keep orbiting like this, following the orbit. Okay, of course, this one looks like a circle. Normally, it's not. It's actually an eclipse. Why eclipse? Because our gravity are focusing on pole, north and south pole. North pole and south pole has stronger gravity. Okay, don't ask me why, because I'm not the astrology engineering. I'm not from there. Although I'm from engineering, but there are many, and the study of planet is called astrology. I'm not the astrology one, because my size can't fit in the astronaut's shirt, astronaut's suit. Okay, you won't see an astronaut with a big belly, correct? So that's why somehow in the pole, normally due to stronger force, they will go nearer like this, nearer, then outside larger, go back nearer like this. Eclipse. But for in your case now, it's just like this. That's why I say when you go Form 6, everything is wrong, because this is just a general one only. Okay, now can you understand? So the planet, okay, can orbit around the sun. Why? Because there's a gravitational force imposed between the planet and the sun. Okay, understood? Yeah. Okay, so try to do. Do we need to do the first one, or we should straight away go to the calculus? I think we have to do lah. I let you do a bit. When okay, can see Yes. Sure, visible. Okay, try to do these two questions.
Only got two, one, two.
Huh? Yeah, two questions only. Why you want to change your new calculator? Is it?
If the answer comes like this, how many digits should we take?
Try to make it 3 decimal place.
So, but our teacher, Nathan said, must we take all the digits?
Within the what?
All the digits, all the digits.
8.6106.
Write down all the digits. He said. some digit like 7 to 8 lah. You want to write down all, he said. Well, this one is too safe. She was trying to ask you guys to play safe lah. So if that's what she said, you better do that lor. She's the teacher ma. Later on you follow me and you follow my way, and then later exam she said salah. Cannot lah, right? Done, let me know.
Yeah. He has done number 2 with the
Okay, then we discuss. Okay, we straight away discuss. Then we know that. Then you can understand. Okay. All right. Calculate the resultant gravitational force of Moon when the mass of Moon is this one. Due to the gravity force of Earth, the mass of Earth is this one, and the Sun, the mass of Sun is this one. So assuming that the force between the force is BB means that the what you call Moon and Earth is perpendicular to the force of moon and I think this one is moon and sun. Okay, so this is the distance between moon earth and moon sun. So by using the formula, first we start with this one, this formula. So we start with this one. For the moon and earth, so Gm mass for moon, mass for earth, divided by the R, the distance between the moon earth square. So you see the force is 1.98 times 10 to the power of 20. Now, the gravitational force between the moon and the sun. So same formula, is just that the mass now we change to moon and sun. So you get the value of that is 4.34 times 10 to the power of 20. So you see, they are, okay, you see, because they are perpendicular to each other. So when perpendicular to each other, so it's like this, like, and this one, 90, correct? Perpendicular, ma. So if I connect here to here, okay, so let's say this is moon and just now this is moon. No, just now we have what you call moon and earth and moon and sun, correct? Correct. So this is the moon to earth, moon to sun. So if I want to see because they are perpendicular to each other, means it's 90 degree. So if this will be the resultant, correct? Force ma, resultant force ma. Let's say this is moon to earth, moon to sun ma. So I want to see the perpendicular, I want to see the resultant force between them. So this will make it a triangle. So we use theorem Pythagoras. So sorry, just now is B, this one is M. So you just use FBM and plus FBB square and then set the whole thing. So you get 4.77 times 10 to the power of 20. This is why we say perpendicular, because perpendicular means 90 degree. 90 degree, then we can use theorem Pythagoras. You understand? Resultant, correct? Remember on the second chapter, I've let you see before the triangle way. This is actually using a triangle. It's just that because it's 90 degree, so we can straight away use Pythagoras only. Okay, done, done. Let me know. I'm actually waiting for you to jot down. All right, now next, a satellite of a mass, okay, m is equal to 200 kg, orbit the Earth at a distance of 30,000 kilometers measured from the center of the Earth. So determine the gravitational force of the satellite. So this is the mass of the Earth. So given that, okay, G is this one, the mass of the satellite is this one, the distance between the satellite and the center of the Earth is 30,000 kilometers. So now he wants you to calculate the distance between the satellite and the center of the Earth. So by using the formula, okay, F equals to GMM over R square. So we just put all inside, you get the value 88.49 Newton. Correct? Correct, Lourdes? Oh, okay. Now, so let's see from the Newton's second law of motion and the Newton's law of gravitation. So we try to derive the relationship between the gravitational acceleration and G. Okay, the what you call the gravitational constant. So you see according to Newton's second law of motion, F is equals to mg. So the gravitational force that causes the object to fall with acceleration g. Then Newton's universal law of gravitation, F is equals to gmm over r squared. This is the gravitational force that pull the object to the center of the Earth. When one, this is the first, this is the second, 1 equals to 2. So mg is equals to gmm over r squared, right? This small m and small m minus each other, so you get G equals to Gm over R squared, where big G is a small one is the gravitational acceleration. This one is a gravitational constant. This one is the mass of the Earth. This one is the distance between the center of Earth and the center of the object. Okay, so this is the derivation, how the derivation comes by. Okay, so jot this down. Together with the petunjuk as well, this one, if you forget. Done, let me know. Done, huh? All right, now let's continue. So you see, based on the diagram on the right, so let's say when there is a, okay, when they, okay, express GH, okay, in terms of the GMR and H, whereas GH is the acceleration due to gravity at the height, okay, from the Earth's surface. G is gravitational constant, M is the mass of the Earth, and R is the radius of the Earth. So we know that according to the formula, okay, I already write down like this, so we follow this one, don't follow this one, this one too neat. The drawing too neat. So you see, F is equals to GMM over R squared. This big alphabet is what you call is the mass of Earth, right? So R squared. So at the height h from the surface of the Earth, the distance from the center of the Earth will be R equals to big R plus h. This is R, this is h. The whole thing is small r. All right. So I substitute this into the formula here. So you get this. F equals to GMM over R plus h squared. Now we know that F equals to mg, correct? So substitute inside. You get mg for the height is GMM over R plus h squared. So G cancel out is GM over R plus h squared. So from here you can see because it's inversely proportional. So when the height increase, so your GH will go down. Okay, means that the farther it is, the further away it is from the surface of the Earth, the gravitational force or the gravitational acceleration will be get lower. Understand? Okay. Now this is how. All right, jot this down. Just draw like this. Easy. Okay. All right, next. So the activity. Okay, now wait. Let me check. You. Okay, I think I will stop a bit early because somehow you see for centrifugal force it will involve pretty long. So I think I stop here for today Okay. I know you're okay for sure. but somehow you too fast reply too fast. Next time lag a bit so that I think so that you can at least show that you are not so